All right, hey everyone, we're going to get right into some notes here on reflections on the coordinate plane. And so it's important to know that a reflection flips a figure over a line of reflection in order to create a mirror image. So it's exactly what it sounds like. It's a mirror image. So if I'm looking at these images below, and I see this smiley face here. It looks like they're looking at each other. This one as well looks like they're looking at each other. So each reflected point should be the same distance from the line of reflection, and this is important to know, on the opposite side. Okay, so if I'm looking at this first image, when I'm saying reflecting over the axis, I would say that this is a reflection over the x-axis because this is my x-axis, this is my y-axis. So this will be a reflection over the x-axis. Okay, and whereas if I look at the second image, I have the y-axis here, the x-axis here. This would be a reflection over my y-axis. Okay. So we do need to be able to know the difference between those. All right, the next thing that we're going to do is we're going to go through some practice examples. Remember, we said that each reflected point should be the same distance away, right? So let's go ahead and look at this first image, or pre-image, and we have W, which is here, which is 2 comma 6. And then you have X, which is 7 comma 4. And then you have Y, which is 2 comma 2. Okay, well, if it's the same distance and we're reflecting over the y-axis, let me see if I can change my color here. Let's change it to red so we can see the difference. This is my y-axis. So to reflect over that, we know that W is 2 points away, so we're going to go ahead and draw W. W prime is here. Y is 2 points away as well, so we're going to put that there. And then X is 7 points away, the exact same distance, so negative 7 comma 4. So that's my X prime. If I were to connect the dots, it's not going to be perfect, but it should be close enough for us to see the image. It looks like they're mirror images of each other, okay, looking at the back end. And the other point that's important to know is that the letters are facing each other. That is a tell that it's a reflection, right? So my new W prime would be negative 2 comma 6. My new X would be negative 7 comma 4. And my new Y would be negative 2 comma 2. So then we ask, well, what happened? The Y stayed the same and the X became negative or opposite. So we're going to say X became opposite. Okay. Y stayed the same. Okay. So algebraically, that would look like this. If x became opposite, the opposite of a positive x is a negative x. And the y staying the same would look like this, y. So this would be my rule here. I'll go ahead and box that for you. Okay, so it should look like negative x comma y. All right, so then if I were to go into the next example here, we have a reflection over the x-axis. So let's go ahead and change the color here so we can see what's going on. Let's say this is reflection over the x-axis. Okay, I know that I have D, which is, well, D, E, F. So D is 2, negative 2. E is 7 comma negative 7, and F is 2 comma negative 7. Okay. If I reflect over the x-axis, it has to be the same distance apart, so I would go 2 away from the line, which would make this a positive 2 comma 2 for D. E would be a positive 2 comma 7, or a 2 comma positive 7, sorry, positive 7. That's F, sorry, I apologize, it's F. And then E would be a positive 7 comma 7. So if I were to connect my dots, we should be able to see how this looks like it's looking at each other, right? So my new points are D prime, which is 2 comma positive 2, E prime, which is 7 comma positive 7, and F prime, which is 2 comma positive 7. Okay, algebraically, well, before I get to algebraically, what happened here? My y values went from negative to positive, okay? So in this case, I would say the y became opposite, okay? And x stayed the same. Okay, so the algebraic rule for this would be, well, y became opposite. Well, first let's do x stayed the same. So x stayed the same and y became opposite. Opposite of positive y is a negative y. Okay, the reason why I'm saying opposite instead of negative is because in this case here we went from a negative 2 to a positive 2. And so that didn't become negative, it became the opposite version of a negative 2. Okay, so it's really important to know that when we're reflecting, the values don't become negative. The algebraic process says they become an opposite version of themselves. Okay, so let's look at number 3, and they want us to reflect the triangle over the y-axis. Okay, and then describe what happened to the coordinates. So if I have over the y-axis, let's change my color here. Let's do blue over the y-axis, which means that my new image should be on this side over here. So R would be 2 away, so R is here. Okay, Q is 5 away, so we go up to 7 and go 5 away right there. There's Q. And P was 7 away, so we're going to go to 7 right there and put our dot. So we have Q. I'm sorry, this is P. Let's erase that. Okay, we have P prime. We have R prime. We have Q prime. Okay, if I connect the dots, I should be able to see my triangle pretty clearly. Okay, and there's my reflection. Okay, so then what happened to my coordinates? Once again, reflecting over the y-axis tells me that the y stayed the same and x became opposite. So I'm going to write that again. X becomes opposite. Y stays the same. Just going to write same. Okay, but y stays the same. So then they want us to reflect the new PQR over the x-axis. I'm going to change colors again. So I want to reflect that over the x-axis. So we know that R is here. So that would be my R double prime because it's the second time we've changed it. P would be here. So this is P double prime. And then Q would be here. Q double prime. Okay, so then we should be able to see what's happening there. So now each of those ordered pairs, once again, let's say if I went from P prime, just to use an example, P prime to P double prime, I have P prime being 7 comma 2, And then to go to p double prime, it's 7 comma negative 2. So once again, when I reflect over the x-axis, the x stayed the same and the y became opposite. So in this case, x equals the same, and this time y became opposite. So the rule here isn't one to memorize, but it's really easy to like look at a picture and then see what's happening. And if I look at the picture, I should be able to look at my ordered pairs and say, well, what happened from x to y to get to my new x and y? And I should be able to say, well, x stayed the same and y became the opposite over the x-axis. With the y-axis, the x became opposite and y stayed the same. I should be able to look at them and say that. So let's go ahead and look at number 5. And I'm not going to do all of these, but let's look at number 5. And number 5 says, Bella thinks that the transformation below represents a translation. Is she correct? Okay. So the first thing I would say is when we translate and slide stuff, translations are the only transformation that preserves everything. Nothing changes. It doesn't flip. It doesn't rotate. It doesn't get bigger, right? So in this case, this looks like the letters are facing each other, which means that it's flipped. So I would write that this is flipped, and then that would let me know that she is not correct. So I would say no, because this is a reflection, okay? And this is a reflection over the y-axis, okay? So the big difference between reflections and translations is literally the orientation. So reflections flip a figure, right? As you can tell, this looks like this went from this way and then it just literally flipped over to go that way. Like it literally took the back end of this and went like that. Okay, that's what happened. Um so let's go ahead and go to number 7 so we can get some practice with the reflecting over x and reflecting over y, and then we should be good to go here. So just a reminder, when we reflect over x, and this is an easy way to remember, if it's in the name, it stays the same, okay? So if I reflect over x, that means x stays the same and y becomes opposite. If I reflect over y, remember, if it's in the name, it stays the same. So in this case, y stays the same and x becomes opposite, okay? So this says x stays the same, y becomes opposite. X becomes opposite, y stays the same. Like those are the difference between the two, okay? And when in doubt, draw a picture, okay? So let's look at letter A, 6 comma 8. So to reflect over x-axis, x stays the same, and y becomes opposite. So that means negative 8. Okay? If I reflected over y, the original, that would say x becomes opposite, which was negative 6, and y stays the same. So 8. Okay? You don't have to do the ordered pair brackets, but that is something that's a good practice. Okay? Then if I'm looking at B, reflect over the x-axis, negative 5. So negative 5 stays the same, negative 5, and then 1. Then on the other one, it would be the opposite of negative 5, so which would be positive 5, and y stays the same, which would be 1. Oh, so look, I made a mistake here. So look at this right here. Notice if x stays the same and y becomes opposite, the opposite of positive 1 should be a negative 1. Okay, that's important. See, to pay attention to what we're writing, okay? So then if I look at letter C, reflect over the x-axis, 10 stays the same, and then we do the opposite of negative 9, which will be a positive 9. Okay, then to reflect over y, well, x becomes opposite, so negative 10, and then we have a same y, which will be negative 9, so on and so forth. Okay, so as you go through the rest of these, and I recommend you try these on your own and see if they make sense. Remember, x stays the same for reflection over the x-axis, and y becomes opposite. Okay, for this one, for reflection over y-axis, y stays the same, and x becomes opposite. The order does matter here, and once again, when in doubt, like draw a picture, draw a graph to see what's happening. But that's essentially the lesson. So if you can understand this concept here, when they say reflect a figure, start with one point at a time and then see if your points are indeed matching what this rule says. If it matches, you've done your transformation correct. So if you have any more questions, please send a message, send an email, get with your teacher, ask for tutorials. Well, hopefully this is helpful for you. And until next time, bye. Now, if you're still on here, the homework practice is just, can I look at something and say what happened? So number one, point D says, do I reflect to the x-axis or y-axis? So it says from -9, -8, from 9, 8. So what changed there? It went from x, and x stayed the same, and then y went from negative to positive. So that says that y changed. So if it's in the name, it stays the same. X stayed the same. This is a reflection over the x-axis. Okay? If I look at number 2, it says the figure is reflected from quadrant 2 to quadrant 3. Well, if I need to know my quadrants to be able to do that, so this is 2, this is 1, this is 3, and this is 4. So from 2 to 3 tells me that it's a reflection over the x-axis. Okay? Number 3, if I look at that visual, that is very clearly the y-axis. Okay, so I'm going to skip around so you can see some more examples here. Let's look at number 9. They want us to be able to reflect this over the y-axis. So to reflect over the y-axis, remember, once again, if it's in the name, it stays the same. So that means the y value stays the same. The x-axis changes. So that means that if t is -2 comma 6, then that means that t prime will be 2 comma 6. Okay, so then I go up here and put a point for t. Okay, a would be, if a is -7 comma 6, well, a would be 7 comma 6. Okay, then we'll put my point up there. Okay, there's my a. M, if it's at -8 comma 2, the new m would be at 8 comma 2. There's my m. Okay, and then h, if it's at -3 comma 2, then it's going to be at 3 comma 2. And there's my h. And these are all prime notation to let you know that they're new. Okay, so if I did this right, which I believe I did, I should have points that say that the x value changed and the y value stayed the same. Okay, so that's important to know. Okay, so then if I looked at this picture number 9, and I'm going to use number 10 to answer those questions, what happened to the shape? Did it change size? No, so we're going to say it's the same. It didn't change shape either, right? So the same. So same shape, same size. Did the orientation of the figure change? So we're asking, did this happen? And in this case, yes, it did happen. So we're going to say changed. Okay, and the last one is, did the orientation of the vertices happen? Well, it didn't rotate, it didn't do this, so that would be considered a same. So with that being said, we went through some practice problems, we went through some notes. Hopefully you have a better understanding after this video, and this for real is my sign off. Until next time, bye. See you guys later.